Okay, so fractional indices. So everything we've talked about as indices so far have been whole numbers or whole integers. Now we're going to be talking about the fractions. So the fractional indices, we can define them as the following. So let's say we have a to the power of half. Well, we're going to write that as the square root of a. And you might recall that whenever we have a square root of a, there's technically a little 2 sitting up here, but we don't have to write it. When we have a to the power of a third, that's the same as the cube root of a. And you might be able to see what the pattern is that is forming. So a to the power of 1 over n is our general sort of rule. So that is the nth root of a. Okay, so this is always talking about the non-negative root of a. Okay, so the positive root, and this is the general form for them. However, we can generalize this even further. So let's say that we have a to the m over n. So it's some fraction like 3 on 2 or 4 on 5 or something like that. We can actually change this around even more. So we can use some of our rules. This is a to the power of m divided by n up there, okay? So a to the power of m divided by a to the n. So what we can do is we can see that this is the same as a to the power of m, okay, to the power of 1 over n, because remembering that, well, actually, let me rewrite it like this first. So this is the same as a to the power of m times 1 over n, okay, which is the same as, so m over n is the same as m times 1 over n, so this is the same as a to the power of m to the power of 1 over n, okay, which is then the same as the nth root of a to the power of m, or just the nth root of a to the power of m, like that, okay? So the general form for so in general, let me write it down. In general, a to the m over n is equal to n, the nth root of the mth power of a. Okay, so this is our general form for this one, okay, and we can go back and forth based on those. And that's what we're going to do, is we actually, in these examples coming up, is we're actually just going to practice going back in between each of the others. So all of our rules and indices and index laws still apply to these fractional indices, okay? It's just now that they're fractions, we can change them into a new format, okay? And because we've already dealt with surds in some cases, we actually know even more rules that we can do with those. So 16 to the half is the first one. So 16 and a half, well, that's just the same as the square root of 16. Okay, and we know that the square root of 16 is just 4. And we're only talking about the positive one in this case again. Okay, so just the positive one in these questions. So 2 to the power of 5 on 2. Okay, well, that's just the same as 2 to the power of 5 and then the square root of all that. Okay, so that's equal to 2 to the power of 5. Well, 2, 4, 8, 16, 32. So this is the same as the square root of 32. And we're going to leave it like that. Okay, now we're getting fractions of fractions. Okay, so the way that we can do it is we can expand them out. So do the product or quotient of powers. So we'll start off with C. We'll have 9 over 4 to the power of 3 on 2. Okay. So this is the same as 9 to the power of 3 on 2 over 4 to the power of 3 on 2. Okay, which is the same as the square root of 9 cubed over the square root of 4 cubed. Okay. And we know through our index law that's the same. That's just the same as the square root of 9 cubed over 3 cubed. So using our surd rules, so this is the same as 9 cubed on 4 cubed. And I'm going to write next to it using surd rules, which we learned about earlier in the year. Okay, and then let's do part D. So part D has got quite a bit going on. We've got 27 over 8 to the power of negative 4 on 3. Okay, so the first thing we're going to do is going to get rid of that negative. So to get rid of the negative, what we can do is we can just do the reciprocal of our fraction and write our power next to it. So remembering that negative is effectively going to take everything to the bottom that's on the top and everything from the bottom to the top like that. So continuing on, we're going to do our power or quotient and power. So we're going to get 8 to the 4 on 3 over 27 to the 4 on 3. Okay. And this is equal to 8 to the power of 4, or the cube root, I should say, of 8 to the power of 4 over the cube root of 27 to the 4. Okay. We could expand this out even further and actually work out what 8 to the power of 4 and 27 to the power of 4 is, but we don't typically need to, but we can use that other third rule, and we can say, well, this is just the cube root of 8 to the power of 4 over 27 to the power of 4, okay, and we can leave it like that. That's all we would be required to do for these ones, okay, because we've removed all of the negative powers that we need to. Okay, now we're going to go the other way, so write each expression using fractional index. And we're going to start with this one over here, which is 1 over x to the power of, or the square root of x to the 4. So for this one, 1 over the square root of x to the power of 4. Okay, we're going to write that number on the bottom in fractional form. So it's x to the 4 over 2. Okay, because the square root goes on the bottom, so it's only a 2. It's only a 2 root, so it's on the bottom, and then the power of the x is on top. Okay, well, we actually know that 4 over 2, well, that's just equal to 2, because 4 divided by 2, so this is just x squared. Okay, but if we have 1 over x squared, well, we know that's x to the negative 2, and it turns it back into the negative power. So, as much as we wanted to write it in a fractional form, if we can actually go further and turn it into a whole number, then that's fantastic. It's not always going to do that, but in some cases it might. It's always worth having a look and seeing if we can. Now let's do part B. So we've got the cube root of x squared, okay? So when we simplify this one, okay, what we're going to do is we're going to rewrite this just in fractional form. So the cube root is on the bottom of the fraction, okay? And the power is on the top. So that's just the same as x to the power of 2 on 3. Nice and easy. Now C, a little bit trickier because the 3, or square root of x squared, or the cube root, sorry, of x squared is on the bottom of the fraction. Okay, so we know that 1 over the cube root of x squared, well, we know the cube root of x squared is just x over 2/3. Okay, we know that from the previous question that we just did. And, you know, if there's something that you do know, you can just put it straight in. You don't have to, you know, do all the expansion again. You can just put it straight in. But because it's on the bottom of the fraction, we need to put it on the top. Okay, so to put it on top, we change it to a negative, and it's going to go like that. Okay, so that's pretty much it for the fractional indices. There is one last thing I want to mention because, you know, fractional indices make up most of the stuff that we do based on this sort of, you know, indices stuff, like it's usually fractions or something like that. Negative numbers do not have square roots, so it follows that you cannot find a root for an even denominator that is negative. So for example, we can't do, so negative 64 to the half. We can't do this, okay, because there's nothing that I can, you know, there's nothing that I can square to get to negative 64. However, I could do, so cannot do. However, I could do negative 64 to the 1/3 because we can have cube roots of negative numbers. So tick, we can. Okay, and we know the answer to that anyway because, you know, well, that's negative 4 because, whoop, that's not what I wanted. So because negative 4 times negative 4 times negative 4 is equal to negative 64. Okay, because negative 4 times negative 4 is 16, and positive 16 times negative 4 is, negative 4 is negative 64. Okay, now powers of zeros are only defined for positive indices. If the index is negative or 0, it is then undefined. Okay, so for example, we can't have something like negative 3 to the power of 0. Okay, we don't do these ones. We just worry about the positive ones. Okay. And with that being said, the last thing that we need to talk about is irrationals. So with irrational powers, okay? So let's say we decided we want to work out what 2 to the power of pi is equal to. Now 2 to the power of pi, if we were to take a sequence that looked like this, so this is 3, and then 3.1, and 3.14, and 3.141. So if we were to, do these powers instead of what pi is, we can actually work out what 2 to the power of 3 is. We can work out what 2 to the power of 3.1 is, okay? We can work out what 2 to the power of 3.14 is because they're all rational numbers. We can turn them into fractions. 3 is just 3 over 1. 3.1 is the same as 31 over 10. Is the same as 314 over 100. Like, we can work those out using index laws. So there is no properly defined value for 2 on pi. But what we're saying is that we can get really, 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 really close to pi by the bigger and the bigger and the bigger we take that, well, the closer and the closer and the closer we take that decimal out to pi. So because we can also pick a number on either side of pi, okay, that's really, really, really close to pi, 3.14 and 3.141 and 3.142, those are 2 numbers either side. It must mean that pi must be between, 2 to the power of pi must be in between those 2 values there. Okay, so with that being said, that's the end of the fractional indices section. Okay, and that's all that is needed for the fractional indices section. So nice and easy one for us.